All right, we're back. We are on page 5 of notes 4 of Calc C, and we're talking about infinite series, right? So we looked at geometric series, we looked at partial sums of series, we looked at a bunch of things, and now we're just like kind of practicing a little bit. So let's see if we understand this. So this question is, I mean, not exactly, but it starts to get into the idea of like, if you're in AP Calculus, you're going to take the AP exam. This one starts to get into like, how are you going to deal with these things? So let's take a look at this problem. So we're given that f of x is equal to the sum from 1 to infinity of the quantity x over 3 to the n minus 1. So this is kind of like maybe the first time you've seen this where a function, so f of x, is defined in terms of a summation. It's not a problem. It's just a little weird. So for the given values of x, determine if the function converges to a value. If so, find it. Or diverges, in which case say y. All right. So here, if I'm going to try to find f of 4, for example, f of 4 would be, if it existed, the sum from 1 to infinity of 4/3 to the n minus 1. So I immediately recognize this is geometric. So geometric, where r is the thing being raised to the n, so it's 4/3. And since 4/3 is greater than 1, this diverges. Oh my God, what am I trying to write here? Diverges. T-I-V-E-R-G-E-S. Sometimes I have to spell it out loud, just to, like slow my hand down so it can actually like do the job. So f of -2 is going to be the sum from 1 to infinity of -2/3 to the n minus 1. All right, so this, I mean, they're all going to be geometric. This one's geometric, and so r is -2/3. The absolute value of r is less than 1. Therefore, this converges. Okay, so what does it converge to? So this is going to be equal to, I'm going to move this down so that things are like in a line, I guess. It's going to be equal to, so it's the first term. You get the first term by taking this value and subbing it in to everywhere you see an n, basically, right? So that's going to give me -2/3 to the 0, so it's 1 over 1 minus the common ratio, or r, which we've already identified in a couple places, -2/3. So what do we get there? We get 5/3, 3/5, I think. It's not a great 5. So these problems are pretty standard. You just want to see like, are you going to get the absolute value of r to be less than 1? If so, just use the formula. If not, just say diverges and explain why. So here, we're going to try to find f of pi. I'm going to say f of pi does not exist, right? Because the series doesn't converge there. So we would have to try to find, because r would be pi over 3, which is greater than 1. Therefore, the sum diverges. So we don't even have to bother with it. On the other hand, e is less than 3, so we do have to bother with it, and it's kind of annoying. So f of e is going to be, they really like to use pi and e in your series, because I don't really know why, actually. I mean, I guess because you can make more interesting geometric series if you include pi and e, because it's like, it introduces this notion that, oh, maybe you won't know the values of pi and e and their relative I don't know, magnitudes or whatever. So this, it's going to be the first term. So first term is take this and sub it in for n. So we get that to the 0, so 1. 1 minus the ratio, which is just e over 3. So, I mean, should I simplify this? 3 over 3 minus e, I guess. There you go. All right. So we were able to find 2 of them. We were not able to find 2 of them. And it just comes down to like, what's r? Is the absolute value of r less than 1? If it is, you're good. If it's not, then, you know, more. You just say that it diverges and you're good. For what values, for f of x, what are all values of x for which the function will converge or have a sum? So converging and having a sum, same deal. So this is geometric. So I'm going to say f of x is geometric. with r equal x over 3, therefore converges for the absolute value of r, so the absolute value of x over 3 less than 1, which is the same as the absolute value of x less than 3, which you could totally leave, which I think I'd be fine with. Or if you wanted to, you go like a step farther and say or -3 to 3. So definitely gonna have a sum every time the value you're trying to sub in is between -3 and 3. So if you go back and look, you knew immediately this wouldn't work because it's not in that interval. This will work, and this won't work. So it's actually, we're doing it in the wrong order. Like we really should have found that interval first. So this is called the interval of convergence for this thing. So it's the interval on which the x values that you sub in will always give you a convergent series. So the interval of convergence, really, it's similar to the domain of a function. I kind of think of them as sort of the same thing. It's like functions have domains and then series have intervals of convergence. Because like if you're not in the interval of convergence, like it's not really useful anyway. So I think of them that way. So find a function g of x equivalent to f of x on the interval of convergence. All right, so f of x, I don't know why I did that. I mean, it should just say like find a function to which f of x converges, but it doesn't say that. So since f of x is the sum from 1 to infinity of x over 3 to the n minus 1. So this is geometric. So this is going to be, the first term is you take 1 and you sub it in here. So you get something to the 0. So you get 1 over 1 minus the ratio, which gives us 3 over 3 minus x, where the absolute value of x is less than 3. So I'm going to say, therefore, g of x, I guess, is 3 over 3 minus x, which is like a way faster way of finding this. So here, if we go back, just to indulge, we're saying that, oh, wait, I forgot the domain. Hold on. Even though, like, I forgot the domain, even though the domain is here and here, I just forgot to write it. So it's really common to write it with the absolute value. So don't like stress about that. Just, do it and move on. All right, so if we go back, the beauty of having the sum, the like closed form is what this is called. So I don't need an infinite series. I just have this, right? So when I have a value that's in the interval, so -2, for example, to find the sum, all I need to do is plug -2 in here. I get 3 over 3 minus -2, 3 over 5. I get this. I don't really need to think that much. And then here you can see we got 3 over 3 minus e, which makes sense because e is in the interval. So a thing to look out for, though, is that the closed form, 3 over 3 minus x, if you ignore the domain, there's an infinite number of values you can plug in that don't really work for this series. So this, if I had forgotten the domain, I could plug 10 in there, and I would get 3 over -7, right? -3/7. It just doesn't make any sense. That's not the sum of any, in this context, it's not the sum of a geometric series. It's just like some garbage thing. So watch out for that. If you don't notice that, you're in for some mistakes. So should I do this one here? You know what? I'm gonna cut the video. I'm gonna come back in the next one and do the rest of this. So I will see you there.